Hello everyone, so this is going to be the first section of Unit 2, Rates of Change and Tangent Lines. And essentially we're going to introduce ourselves to probably one of the two biggest topics in calculus, which is derivatives. Alright, so I highly recommend that you try to pay attention to the concepts in this section, because these concepts are going to carry over into more difficult, higher level problems that if you don't really understand the concept, then you're going to struggle a lot. So the first thing you have to understand is that a derivative, what that represents is the slope of a tangent line. So, pen working. The slope of a tangent line for any x value of a function. Okay? And of course, sometimes they interchange the words slope and rate of change. You just have to remember that they mean the same thing. Rate of change. Right? So really, what it boils down to is like if I were to have some kind of graph, right? And let's say I have just a wonky looking graph like this, right? If I went ahead and I drew like a line at any tangent point, something like that, right? There's this just like any other line, this is going to have some kind of slope, right? Or m. All right? And what essentially the derivative is going to help us determine is what is the value of that slope. And the derivative can also tell us the slope of the function here. It could tell us the slope of the function here, or of the tangent line of the function there, slope of the tangent line of the function there. And that's what we're ultimately trying to determine when we're doing the derivative. And a different notation that we can often use for the derivative is f prime of x. So if you're given a function f of x, then f prime of x represents the derivative of that function. So before I actually get into the details of of how to figure out what a derivative is, I think it's important for us to kind of revisit what a rate of change is way back from algebra. So rate of change, this is the formula, f of b minus f of a over b minus a. And really, if you kind of look at that equation, it kind of looks similar to the slope equation, the y2 minus y1 over x2 minus x1, right? They're both just different variations of slope or rate of change. So occasionally I have seen in old AP exams them go ask rate of change problems. So let's just kind of work out a couple of those just to kind of remember how to do it. So it says over here, what is the average rate of change of the function f given by f of x equals x to the fourth minus 5x on the closed interval 0 to 3. So again, if we were to apply this formula right there, right, first we got to figure out, well, let's say that this is a and b, and let's figure out what f of b is first. So f of b is 3 to the fourth minus 5 times 3, and that's equal to 81 minus 15, which is 66, right? So then if I did f of a, well, that's going to be f of 0, so that's 0 to the fourth minus 5 times 0, which is pretty much just 0. So if I did f of b minus f of a divided by b minus a, then you get 66 minus 0, right? Divided by 3 minus 0. And that just gives us 22. And that's our final answer for that. All right. Similarly here, if I were to work out the rate of change of this function over this interval, well, again, sometimes the interval will be in the form of an inequality. So this is a and this is b, right? So if I did f of b, well, that's equal to e times pi times cosine of pi. E to the power of pi. So that's e to the power of pi, and then cosine of pi, well, if I look at my unit circle, that's over here on the left side, so that's -1, okay, which is just negative e to the pi. And if I did f of a, well, that'll be e to the 0 times the cosine of 0, right? Anything to the 0 power is just 1, and then cosine of 0 is also 1, so that's 1. So then if I did f of b minus f of a divided by b minus a, then I get negative e to the pi minus 1 over, and then pi minus 0 on the bottom is just going to be pi, and that's our final answer. All right. And last but not least, sometimes they'll go ahead and give you a problem where they ask you to find the rate of change of a set of values in a table, right? So let f be a differentiable function with selected values given in the table below. What is the average rate of change of f over the closed interval 0 to 10? So again, this is A and this is B, right? So really there are only 2 points that I'm looking at here. First one being this one and the second one being that one. So we can kind of think of this as like point A and point B. So if I did f of B minus f of A divided by B minus A, well, let's see, f of B, that'll be pretty much the function at B is equal to negative 20 minus the function at A is equal to 5, all divided by 10 minus 0. So I have negative 25 over 10, which reduces down to negative 5 over 2. All right, so that's kind of the basics of a rate of change. Now, essentially, with the rate of change, what that's telling us is what is the slope really between just 2 random points. So if I kind of looked at this, let me just kind of go ahead and draw a graph here. Let's say I had a graph that looks like this. Let me try to make it look somewhat nice. So something like, I don't know, something like that. Right? Essentially, a rate of change is telling us, let's say I had a point here, and let's say I had another point there. And if I were to draw a line between those two, okay, then the rate of change is going to tell us, or well, this will have a slope. Will have a slope, right? And the rate of change, or the slope, it's essentially between 2 points. Right, so if I look at 2 points and I find the slope between them, that helps us determine the rate of change between those 2 points. But what if I had something just a little bit different? Let's say I wanted to know what is the rate of change of just a single point. Like let's say of a single point right there, right, at this x value. Okay, let's call it at an x value c constant 1, right? Well, if I were to draw a tangent line at this point, it's going to look something like this. All right, and this slope of the tangent line can be determined by the derivative. Let's just say f prime of x. All right, so if I found the derivative of this function, I can figure out what is the slope of this tangent line at this point for this x value. Maybe I'm interested in knowing the slope of this x value, right? Let's call that C2. That corresponds to this point right there. And my derivative function can also tell me what is the slope of that line right there. Okay? So all of these things are going to be useful, or making sure you understand this, this principle is going to help you with later problems in the future. So over here, the definition of the derivative formula. Now, I know some of you probably know the shortcut, and that's fine. I'm happy for you. But I still want you guys to understand how to do this the long way, because there are some conceptual questions on the AP exam that use this formula right here. And that's the limit as h approaches 0 of f of x plus h minus f of x divided by h. So we haven't quite escaped limits yet. You're still going to see some problems that involve limits, and especially for the derivative. And this is kind of how every textbook, every calculus class will have you start taking derivatives, is by using this formula. So just to kind of put that into practice, all right. It says over here, use the definition of a derivative to determine the slope of the tangent line. The slope of the tangent line derivative for the function at the indicated point. All right, so here we've got a function, and we want to know what is the slope of the tangent line, or the derivative, at this x value. So we have to use that formula for now. All right, we have the limit as h approaches 0 of f of x plus h minus f of x divided by h. So just kind of like if you ever had a function and some value inside of the parentheses, typically what we would do is we would get whatever values inside of that parentheses and plug it in for each x value, right? So when we go ahead and plug this into that function, what we're going to end up with is the limit as h approaches 0 of x plus h squared plus 5 times x plus h, right? So for this, all I did was I just got whatever was inside the parentheses and I plugged it inside of those x values. Then of course we're going to subtract it by whatever just our function was originally. I'll put it in parentheses to remind me to distribute the negative. So that'll be minus x squared plus 5x. And then of course all of this is divided by h. And now essentially what you have to do is you have to expand this, cancel things out, and figure out what your final answer is at the end. So when I go ahead and I expand that out, well that's the same thing as x plus h times x plus h. I don't know why my pen is dying on me. So then I have x squared plus xh plus xh plus h squared, right? I'm not going to spend too much time working that out, but then we have the limit as h approaches 0 of, let's see, we have x squared plus 2xh plus h squared. And then over here we've got plus 5x plus 5h, and then we distribute the negative minus x squared minus 5x, all divided by h. And then from here you got to determine, okay, well what things can I cancel out from the numerator? So you'll notice I can cancel out an x squared and a negative x squared. I can also cancel out a positive 5x and a negative 5x. And essentially all you're going to be left with are terms that have an h value in them. So this is equal to the limit as h approaches 0 of 2xh plus h squared plus 5h, all divided by h. And really, if you know that you have a greatest common factor, or GCF of h from the top, you can go ahead and take that out. So that's the limit as h approaches 0 of h, parentheses, let's see, 2x plus, I'm left with h plus 5, all divided by h. Well, you'll notice that then h cancels out from the bottom and the top. So now if I plugged in 0, I'm not going to have an indeterminate answer. So then when I plug in 0 into this, I'm just left with 2x plus 5, right? So this right here is our derivative function. Okay, so I'm going to go ahead and rewrite this as the derivative of the function is equal to 2x plus 5. And then if they wanted you to know what is the slope of the tangent line of the at x equals 1, you just have to plug in 1 into this. So f prime of 1 is just equal to 2 times 1 plus 5. And that's equal to 7. Okay? So that's essentially how you find the derivative, okay, at an x value. At least this is how we're going to start off doing it. You're going to find out later that this is significantly easier to do, and you wouldn't have to go through this whole process. But to introduce the lesson, I have to teach it to you like this because there are some conceptual questions that would use this formula. So let's go ahead and do this example here. Again, I'm just going to take the limit as h approaches 0 of f of x plus h minus f of x, all divided by h, right? So if I plug in x plus h into this, I'll have, so let me rewrite the limit. I'll go ahead and I'll have, let's see, x plus h squared minus 3, and then all of this minus the original function, so x squared minus 3 divided by h. It's getting a little sloppy. So then this is equal to this one I kind of remember from up there. It was the limit as h approaches 0 of x squared plus 2xh plus h squared minus 3, and then I distribute the negative to get minus x squared plus 3, all divided by h. And then I notice here what I can cancel out. So I know I can cancel out an x squared with a negative x squared, a negative 3 with a positive 3. And then ultimately, the other thing I can kind of, I'm just going to do this all in one step. If I have an h in every term left, I can cancel out one of those h's in everything. So that's going to, one of those h's will cancel out, this h will cancel out, and this h will cancel out. All right? So this is essentially equal to the limit as h approaches 0 of 2x That's it, just plus h, right? So if I plug in 0 in for h, I just get 2x. So my derivative of this function is just equal to 2x. Okay? So if I wanted to know what is the slope of the tangent line at this point right there, x equals 2, well then the slope is equal to 2 times 2, which is simply 4. All right? So again, understand this is the slope of the tangent. I'm going to write it because you guys have to know this. Slope of the tangent line at x equals 1. Again, slope of the tangent line at x equals 2. I'm emphasizing this for a reason, because you need to understand, because a lot of times we're going to go back and forth between derivative graphs and original graphs, and it's going to be really helpful if you know how to know what each thing actually means. So, all right. So over here, this time we have to write the equation of a tangent line. So first we kind of have to remind ourselves, how do you even find an equation of a line to begin with? So, I mean, there are two versions. There's the y-intercept form and the point slope form. Whichever one you feel comfortable with, just go with it. Both equations essentially help you find the same thing. I'm just, I'm so used to teaching, lower level math, and this is so easy for them. So I've kind of already gotten used to doing everything with the slope-intercept form. So that's how I'm going to do this example. So just to kind of review how to do it, it says write the equation of a tangent line that has a slope of 4 and a point 1, 2, right? So again, you got to write what our givens are. We have an x and y value of 1 and 2, respectively, and then we have a slope of 4. So to create a linear equation, we have to, first of all, we have these three values, but we're missing the y-intercept, so just solve for y-intercept after plugging everything in. So if I do that, I get 2 is equal to 4 times 1 plus b. Okay? So then essentially if I just work this all out, I get b is equal to -2. And then our linear equation is y is equal to 4x minus 2. Okay? So this is how you find a linear equation given a slope and a point. And to kind of tie this into what we're actually doing in calculus, if they ask you write the equation of a tangent line for a function at a point, well, obviously up here we were given the point, but we had to determine what the slope is. And if we want to know what is the slope of the tangent line, well, we got to take the derivative of this function, right? So for now, again, we're going to go ahead and do this the long way with the definition of a derivative. But if I did the limit as h approaches 0 of, I'm just going to rewrite the formula because you have to know it, f of x plus h minus f of x divided by h, right? I'm going to plug in x plus h into x squared, so that's the limit h approaches 0. And guys, notice how I'm writing limit at the beginning of everything. Know when to continue to write limit and when to not write it anymore. Once you do the direct substitution at the end, you don't have to write limit anymore. But until you actually go through that process, make sure you continue to write limit. So that's the limit as h approaches 0 of, let's see, where I don't even know. Okay, yeah, x plus h, so that's going to just be x plus h squared minus the original function x squared over h. So that's going to be the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared, all divided by h. My x squares cancel, and really an h is going to cancel out of everything, so I'm just left with the limit as h approaches 0 of 2x plus h. So when I plug in 0, I get 2x. So this is the function of my derivative, right? So my derivative is equal to 2x, and the function that's going to help us determine the slope at any value x. So what value of x do we want? Sorry, I got interrupted. Okay, so it said what is so this is going to be the function of our slope at any x value. Well, the x value we're interested in is obviously an x value of 3, right? So we're going to go ahead and plug in 3 into this. So our slope at the point 3, 9 is equal to, if I plug in 3 into this, I get 6. Okay, so that again is going to be our slope. So we have our x and y value, 3 and 9. We have our slope. Now we can go ahead and create our linear equation. So I have for y equals mx plus b. I plug in 9 in for y, 6 for m, 3 for x plus b. So then b is equal to 9 minus 18 is equal to negative 9. So then our function, or our linear equation of the tangent line is y equals 6x minus 9. And that's the slope of the tangent function at this point. If I were in a classroom, I'd show you through technology kind of how that worked, but whatever, that's fine. So, this example, yeah, this one is, I guess this is one of the tougher examples, and I don't want to make this, I already made the video long, I might as well just finish. So, again, if we want to write the equation of a tangent line for this function at that point, we got to figure out what the derivative of this function is, and this is going to be a little bit hefty. So, if I do the limit as h approaches 0 of f of x plus h minus f of x over h, well, I'm going to plug in x plus h into all of this, so I'm going to end up with the limit as h approaches 0 of 1 over, if I plugged in x plus h into that, I get x plus h plus 3, minus the original function, 1 over x plus 3, all divided by h. All right, so now for this, I got to determine, well, what is my common denominator? Well, my common denominator is simply going to be, let me go ahead and write over here. My common denominator is going to be x plus h plus 3 times x plus 3. Whoops. Sorry. So, yeah, this is what the common denominator is going to be. So if I wanted to determine this, or combine this fraction into 1, I got to multiply the top and the bottom of this one by x plus 3 and the top and the bottom of this one by all of this. So if I multiply the top and the bottom of this one by x plus 3, I get x plus 3 over x plus h plus 3 times x plus 3. And if I multiply the top and the bottom of this fraction by x plus h plus 3, I get minus x plus h plus 3 divided by x plus h plus 3 times x plus 3, right? If I distributed the negative into all of that, I'll have an x minus x, a 3 minus 3, and I'm just left with negative h at the top. So I did that so I didn't use up all that space. But if I have the limit as h approaches 0, that combined fraction is going to become negative h divided by x plus 3 plus h, whatever, x plus h plus 3, it's the same thing, times x plus 3, all divided by h. So then that's the same thing as, again, you have a fraction within a fraction, so you got to do the multiplying by the reciprocal of the denominator. So the limit as h approaches 0 of the numerator times x plus h plus 3 times x plus 3 times the reciprocal of the denominator, 1 over h. H is canceled. Now I'm left with the limit as h approaches 0 of negative 1 over x plus h plus 3 times x plus 3. If I plugged in 0 in for h, then I'm just going to be left with negative 1 over x plus 3 times x plus 3, or negative 1 over x plus 3 squared. All right? So again, these problems can get extremely long, and personally, I can't wait till we're done with this section and we can actually do problems that, or a lot of the derivative rules that will get you through this in a much more efficient way. So I know that my derivative function is equal to negative 1 over x plus 3 squared. So if I wanted to know what is the slope at this point, negative 1, right? So I get f prime of negative 1 is equal to negative 1 over negative 1 plus 3 squared. That's 2 squared, so my slope is going to be negative 1/4. All right. And there you go. Now I can create my equation of a tangent line. Well, I have my slope, which is negative 1/4. I have an x value, negative 1, and the y value is really easy to figure out. I just got to plug in negative 1 into the original function. So that'll be 1 over negative 1 plus 3, which is just 1/2. That's a 1. All right, so now I create my linear equation. Y is equal to mx plus b. I plug in 1/2 is equal to -1/4 times -1 plus b. So then I have 1/2 is equal to 1/4 plus b. If I subtract 1/4, 1/2 minus 1/4 is going to be 1/2 again, right? Because that's like saying 4 over 2 minus, no, I'm sorry. What am I saying? 2 over 4 minus 1 over 4 is 1 over, 1/2 minus 1/4 is going to end up just being 1/4 again. Because 2 over 4 minus 1 over 4 is back to 1 over 4. So b is equal to 1/4. And then my linear equation is y equals -1/4 x plus, no, yeah, plus 1/4. And that's it. All right, so hopefully this was helpful. I'm going to go ahead and end it here. And there's a problem set, so make sure you work on it and let me know if you have any questions. Take care.